Hello there and welcome to our final video of topic 1.2.4. This is now part 3, and in this video we're going to look at modes of addressing memory. And there are 4 modes that are specified within the specification for the H446 OCR Computer Science A-Level specification. So, what are modes of addressing memory? Well, remember the fetch, decode, execute cycle. Through the fetching stage and the decoding stage, we need to actually go and retrieve some information during that process. And it's where modes of addressing comes in. It determines how we actually do the fetching part of that process. So, what is memory addressing? Memory addressing modes determine how a processor accesses data stored in memory or registers during the program execution. And there are 4 addressing modes. We've got immediate, direct, indirect, and indexed. And each one of them has its own characteristics and its own way of collecting data. So let's start off with a little recap on assembly language instructions. If you've not watched part 1, you probably should do. Here we've got a number of instructions: load, store, add, subtract, input, output, end, branching, data store. Great. Wonderful. We've seen it all before. We know the mnemonics, and we talked briefly about the machine code. Now in part 1 I did say that the first number there determines what the mnemonic's going to be. So if it's a 5, it's a load command. If it's 3, it's a store command. If it's 1, it's an addition command. If it's 2, it's a subtraction, so on and so forth. The X's though are the memory addresses that we use. Now we don't always go to a memory address to find the data. We can send data directly, which is interesting. So it's how we get and fill in those X's in the machine code instruction, and that's what we're talking about today. That's what we're talking about. This is all to do with our addressing modes. So let's crack on with the first one. We're going to assume that we've got a word size that is 8 bits in our register. So every clock cycle, those 8 bits are going to be fetched, decoded, and executed. And we've got our 8 bits broken down into 2 parts because we break our register down so we know that we've got an opcode and an operand. And we've got 4 bits assigned to the opcode and 4 bits assigned to the operand. The opcode is the instruction and the operand is the data or the address in which we're going to use as a part of that process. Okay, so the first thing to know in immediate addressing is that the operand or the data to be used is directly specified in the instruction itself. And we know, if we know basic binary, we can say that the opcode here is, let me just fetch my pen. Yep. So the opcode is 1, 2, and 4. Okay. So this is the opcode is 5, which is an LDA command, some kind of load, and we've got an 8 there, and we've got 2 there. So that's 10. So we're going to load 10 in the immediate addressing here. So there's no need to access memory with immediate addressing, as the data is actually part of the instruction, which is the operand. It's fast because there's no additional memory lookup, and typically it's used for constants or fixed values. Now, immediate addressing allows simple access to data with no fetch required, but is limited by the size of the operand. So you know, with 4 bits here, the maximum piece of data that I can actually represent is 15 here with 4 bits. So here I've got a table which we'll see in each one of these different addressing modes here with immediate, direct, indirect, and indexed. And you can see what that would look like if I was to write that down. So I've got load #10 here, and here #10 is the immediate value, and it is directly loaded into the accumulator. So that's it. That's immediate. It's the data itself, and it's accessed directly. There's no need for further lookup in memory. So on to the next one, and we're talking about direct addressing now. Same opcode, same operand, but this time the operand does something slightly different. It's no longer the actual data, however, it is a memory address. So the instruction contains the memory address of the data, and the processor fetches the data directly from the specified memory address. And that's simple to understand and use, but is limited by the size of the memory address field in the instruction itself. So to cobble that all together, direct addressing allows data to be fetched from memory. Data can potentially be larger in size than that of immediate addressing, but the address range is limited by the size of the operand. So here in this example, I've still got a load command because my opcode is 5 and then my operand is 10. But 10 is not the data because that would be immediate addressing. 10 is the memory location in which I need to go to extract the data from and load it into the accumulator. So load 10, here 10 is the memory address where the data is stored, and its value is then loaded into the accumulator because my opcode is 5, and that's a load command. That's what it looks like in our different addressing modes. So on to the next one. Now, indirect addressing. So in this one, again, opcode is the same, it's a load command. The operand is still 10. However, 10 is still an address. And with an indirect addressing mode, the instruction contains the address of a memory location where the actual address of the data is stored. So, make this really simple for you. Before, the opcode and operand in direct was you would jump to memory location 10 and load the data into the accumulator. In indirect addressing, we jump to memory location 10, we read what's in there, and it's another memory location, and we jump to that one to then retrieve the data. Okay, it's indirect. So we jump memory location or memory address again, and we find the data. Okay, so this involves two memory accesses, one to get the effective address and another to fetch the data. And it provides flexibility as the actual address can change dynamically, and indirect addressing allows a larger range of addresses to be accessed as address fetched. However, multiple fetches required to access the data itself. And that takes time. So to fetch data is a long process. So this is why things have to be stored contiguously, or it's better if they are stored contiguously, one after another across the memory device itself. So there we are, we've got load 10. Here 10 is a memory location that stores the address of the data. The processor first fetches the address from 10 and then accesses the actual data after that. And then finally, our fourth memory address, or mode of address should I say, is indexed addressing. So as soon as you hear the word index, I want you to start thinking about an array. An array which holds multiple elements in an ordered way, starting at 0 onwards. I've got the same opcode and same operand again. Now, this combines a base address, which comes from the instruction, with an index, which is stored in a register to calculate the effective address. So this is useful for arrays or tables where data is stored sequentially. And again, it needs to be contiguous because we have to go one after another from index or array position 0, position 1, position 2, position 3, etc., etc. It allows for the index to change dynamically during the program execution, and indexed addressing allows the index register to be manipulated to address data stored sequentially, i.e. in an array for this. So you can see here I've got load R1, 10, R2, and here 10 is the base address, and the value in register R2 is added to it to compute the effective address. So for example, you could go to memory location 10 and then load R2, so whatever number's in 10, load R2, which could be 1, and you could increment by 1 every time. And this would enable you to change and go to different memory addresses even though you've only got one memory access here. And then when you withdraw that information and pull it back, it'll get stored in register 1. You can take register 1 out of that command there and it'll go to the accumulator. But just for you and just for sort of the complexity of our A level, we just need to know that index addressing takes us to a memory location. We use a second memory location to actually provide us with our value that will increment what we're doing or move us through a data structure sequentially. And in that index or in that array, we'll have multiple memory addresses, and they can be changed dynamically while the process is running. And that's really handy to do while you're computing lots of programs and fetch, decoding and executing. So here, let's just summarize that for a second. Immediate, direct, indirect and indexed. So in immediate, data is part of the instruction. There is no memory access at this point. It's used for constants or fixed values. Direct, the address of the data is in the instruction itself, and we have one memory access here, and it's very simple. We just go directly to the memory address and load the data. Indirect has two memory accesses because the address of the data address is in memory, and that's good for what we call dynamic memory referencing, where we jump to a memory location and then to another one to get the data. And then the last one, indexed, we've got our base address, and then we've got the index in a register, and we have one memory address there, and that's really efficient because it allows us to move through an array or a table sequentially. So key takeaways: immediate is fast but inflexible, direct is simple but limited to specific addresses, indirect is flexible but slower because you've got multiple memory accesses, and then you've got indexed, which is ideal for structures like arrays or loops and iteration. So here we've got an exam question. Now my recommendation is to give that a read and pause the video and see what you think you would tick as a part of immediate, direct, relative, or none of these. At this stage, I'm wondering what you're thinking, because it says in this question, place ticks in the table to show which statements apply to the modes of addressing, shown for a low-level instruction in the form add 1, 2, 3. And this is worth 4 marks, so I assume it's 1 row per mark, obviously. And it says here, addressing modes immediate, direct, relative, or none of these. And you're probably thinking, excuse me, John, what on earth is relative? Relative is actually an addressing mode, but it's not covered in the specification, so I'm not quite sure what OCR are playing at in terms of asking you about this. However, it might just be a red herring, so let's see if any of them actually do fall in the relative, and I'll explain it if they do. 1, 2, 3 is the address of the data to use. Okay, so if the 1, 2, 3 is the address and not the actual data, if it was the actual data, it would be immediate, wouldn't it? But because it's the address, I'm going to go with direct on this one. Then the second one, it says add is an operand. Well, okay, good for you. That's got nothing to do with modes of addressing. It says the data to use in the calculation is 1, 2, 3. So because it's the data, the raw data being used, I'm going to go for immediate on that one. And then here, the bottom one says the address. So again, not data, this one. The address. So immediately, because it says address, I'm thinking it's not immediate. That's gone. The address 1, 2, 3 holds a value, which is the address of the data to use. So this is address, which follows another address, and that is indirect. So that is none of the options that we've got here. So I'm going to have to tick this one. There we are. Nice easy 4 marks there. There we go. Let's have a look if we're right though. Oh, yep. Perfect. We are correct. Thank goodness for that. This one. So next one here, next exam question says, Kaz is studying low-level languages. She has lost some of her notes on modes of addressing, but has the following part of an example. Address in the current instruction register is 3. Address to be used is 3 plus 11 equals 14. Name and explain 2 modes of addressing that this example could show. Now the first one that I would explain here, you've got 2 modes of addressing, and the one that we know is indexed addressing. So remember from before, we have our base address, which is 3, and our additional one, which makes the total result itself, or the total address itself. Okay, so indexed addressing, and that modifies address 3 because it adds 11 to it from an indexed register. So I would say 3 is the base, adds 11 to it, and this comes from an indexed register. Okay, because the CIR is involved, so the index register provides that number and the addition gets performed. I remember what index address is good for. It's good for arrays, isn't it? Now, if I was to explain the other one, the other mode of addressing, again, this is another thing that I just said in the previous question. I think it's relative addressing. So what is relative addressing? So here, relative addressing, it's going to use an offset. And the offset is 3 because that's the address that's been provided. So relative uses an offset, and in this example, the offset is 3, and that is used to calculate the real address from the base address, from base address 11. Now, I think it might be important if I do cover relative addressing anyway, if OCR are going to try and pull the rug from under us here on these kinds of questions. So, relative addressing uses an opcode and operand like normal, but the key here is all about the offset value. So, relative addressing mode uses an offset value or displacement that is added to the current program counter to calculate the effective address of the data or instruction. And this mode is commonly used for branching or jumping to another part of the program. So primarily, it's used for program control instructions like jumps and branches, and it offers flexibility in code, relocation, and dynamic execution flow. At the bottom right hand corner, you can see there's an assembly language command here. It says BEQ, which you've probably not seen before, but it means branch if equal, R1 label. So if R1, the register 1, equals 0, the program counter is updated to point to label. Label's obviously a label in my assembly language set of instructions. The offset to label is added to the current program counter to calculate the target address. So think about what an if statement does. A control statement happens, and then it's either true or false. If it's true, it's going to point at a different set of instructions. If it's false, it's going to point at a different set of instructions. The relative addressing changes the program counter to point or start at the right set of instructions. If it didn't do this, the program counter would just continue from 0, 0 and 0, 1, 0, 2, 0, 3, 0, 4, etc. all the way down till it reaches the bottom. But branching means that we have to jump or change direction and load a new set of instructions in and change where the program counter is actually pointing. And that's what relative addressing is actually for. So, if we go back to what we looked at before, knowing this information now, Kaz, with her low-level languages, it says address in current instruction register, CIR is 3. Address to be used is 3 plus 11 equals 14. Name and explain two modes of addressing that this example could show. We've got relative addressing because it uses an offset 3 to calculate the real address from the base address 11. And we've got indexed addressing. Modifies address 3 by adding the number 11 from the indexed register. Okay. What about this question then? Little Man Computer Assembly Language program is stored in memory as shown in figure 3.1. In this variant of LMC, the symbols and, that's an ampersand, and hash are used to denote different modes of addressing. Given that the output is 17, state the addressing mode represented by each symbol. So we can see here right at the top, we've got the first one, ampersand, that is 7. So it says LDA ampersand 7. So what I would do here is actually put in some numbers and try and dry run it to see which addressing mode it actually is. So LDA and 7, if I just put in my accumulator here for a second, if I was using immediate addressing, it would be 7 that gets loaded in directly. Then I'm going to add whatever's at memory address 4. Now, if I was going to add 4 to this directly, again, in immediate addressing, what is 7 plus 4? So it could be 7 plus 4, which equals 11. Now, it says the output is 17, so that's not going to work. So it's definitely not immediate and immediate addressing. Let's try immediate again with the second number. What about if it's at the address 4? So that's 6. So 7 plus 6 is 13. Again, that doesn't work. So it's not immediate and it's not direct addressing. Let's try immediate and let's try indirect then. What that means is I would load 7, I would then add whatever's at memory address 4, so I'll jump to memory address 4, and then it says 6, jump to memory address 6 and load 10. That looks better because that would be 7 plus 10, which is 17. So I think I might have just stumbled across it there. That means this would be immediate and this would be indirect addressing. And when I think about indirect addressing, just remember you've got address which goes to another address, and immediate is direct, it's the data itself, okay? The data itself. Question is, am I right though? Immediate addressing and indirect addressing, there we go, yep, excellent. So that was 2 marks. And this was a cheeky question. This was a 12 marker on modes of addressing. It says in assembly language, different modes of addressing memory can be used. Discuss the different modes used. You should include how the operand value is determined, what an operand of 27 would refer to in that mode, and the reasons for requiring multiple modes of addressing. So it's giving you some bullet points to actually work through. However, when you're approaching 12 mark questions, these are banded. They're not given because you've said something that's factual or true. The marks are given in bands. So let's have a look at what that would mean. The first band, the high band, is 9 to 12 marks. So the candidate demonstrates a thorough knowledge and understanding of different modes of addressing. The material is generally accurate and detailed, and the candidate is able to apply their knowledge and understanding directly and consistently to the context provided. Evidence and examples will be explicitly relevant to the explanation, and the candidate provides a thorough discussion which is well balanced. Evaluative comments are consistently relevant and well considered. there is a well-developed line of reasoning which is clear and logically structured. The information presented is relevant and substantiated. So when you're looking at this here, although it doesn't actually talk about a specific mode of addressing, you need to bring them all into the question and compare and contrast them. In the first AO1, remember, you are going to state the facts of what you know. It's very clean cut. Just tell me facts and information. So it says down here, immediate addressing is where the operand holds the actual data to be used, where there's no address referenced. Direct addressing is where the operand holds the address that holds the data to be used. Indirect addressing is where the operand holds an address, which is where the data is to be used, is stored. And then you've got indexed addressing is where the operand holds an address, which is an offset using an index register to find the true value of the data to be used. Again, all you're doing is just stating facts. There's no relation to the question scenario or the data that's been provided so far. That comes in AO2. This is where we start to link it now. So we've got immediate addressing of operand 27 would refer to the value 27 exactly. Direct addressing of operand 27 would tell the processor to fetch the data held at memory address 27. Indirect addressing of operand 27 would tell the processor to fetch the data held at 27, which itself would then be used as an address to fetch data from. And then finally, indexed addressing of operand 27 would be added to the value of the index register that would then be used as an address to fetch the data from. And finally, you've got to then give your opinion based on what you've done so far. So which one would you recommend and why? Compare and contrast. Immediate addressing allows simple access to data with no fetch required. That's great, but it is limited by the size of the operand. Direct addressing allows data to be fetched from memory, and data can potentially be larger in size than that with that immediate addressing, but the address range is limited by the size of the operand. That is so badly worded. I cannot believe OCR released that. Indirect addressing allows a larger range of addresses to be accessed as addresses are fetched. However, multiple fetches required to access the data. Indexed addressing allows the index register to be manipulated to access data stored sequentially, i.e. in an array or iteration or a loop, I suppose. So, 12 marks, approach with AO1, AO2, AO3. Give me the facts and opinions. Give me the facts only. AO2 related to the question. AO3, give me your opinion based on what you think. Good points, bad points, compare, contrast. Now, that is the end. That is the end of 1.2.4. It was a very, very busy topic, this one, split into parts. Your challenge now is to ask your teacher for exam questions, try some things out, get some feedback, and then keep working on it. Rome was not built in a day, so you've got to keep practicing and revising these things. Try it with different data and see where you get to. Okay, well done. We will see you in the next chapter now, and I look forward to seeing you soon.